Ladies and gentlemen, hello and welcome, coming to you once again, not quite live from One Take Studios, where we are talking about rate of change and slope today. Rate of change and slope. Really, these are two expressions that essentially refer to the same thing. I'll give you a slight distinction for them a little bit later on. But to me, it's really important that you not just know formulas and random things about this, but that it actually makes some sense to you. All right, so I've started with two staircases here. Here's my first staircase, here's my second staircase. If you had to say, which of these two is steeper, which one would you pick? Which of these two is the steeper staircase? I'm hoping you said the first one. If we look at this, this goes 2 blocks up, 2 blocks over, 2 blocks up, 2 blocks over, and we can see that pattern as it continues here. This is what's called a constant rate of change because it's always changing by the same amount. This set of steps also has a constant rate of change. It's going 1 block up, 3 blocks over, 1 block up, 3 blocks over, and again that pattern continues as it goes along. They both have 4 steps, 4 steps, and 4 steps, but let's look at the difference overall, shall we? This set of steps, beginning to end, tell you what, let's get a slightly better way to look at this, shall we? Beginning to end, what would this be? I'm going to kind of put a line so we can tell a little bit better. So from here to here, there we go, beautiful line. And from here to here, and again, stunning, yay, happiness and joy, beautiful line. Okay, so we've got these two going on saying, all right, if I look at that, well, this definitely looks more steep than this one. All right, beginning to end. Here's the beginning, here's the end. This is 4 steps. How high does it go? How many boxes up? Can you tell? From here to here, so we're talking this is going to be up 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 8. This is a grand total of 8 boxes up. So 8 up. And from left to right, how far are we going here? We're talking 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 8 across. So 8 up and 8 across. As opposed to my less steep staircase, beginning to end, goes up 1, 2, 3, 4 blocks only. So this is going 4 up. And then across, beginning to end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going 12 across. Okay, so if they're both 4 steps, which one is steeper? This one. Why? What's a good way we can express this rather than just counting? Although counting is a really nice idea, and if you can see that, that's really cool. What if we thought of rate of change and slope, again, essentially the same thing. What if we thought of them as a ratio, as a comparison? All right? How do we often write ratios? How do we often write comparisons? We put them in a fraction format. So if we look, this one goes much higher up compared to how far it goes across, and this one doesn't go up very high, but it does go farther across. So what if we compared the rise, how far the steps go up, as opposed to the run, how far the steps go across? Ladies and gentlemen, this is one of the most common understandings of slope right here, rise over run. And that's what slope is. It's just a comparison. How far did we go up versus how far did we go across? So if we use that over here and take a look at this, well, okay, so 8 up and 8 across, that's rise, that's up, and across is run. So this would be 8 over 8. Well, oftentimes we don't leave our fractions like that. 8 over 8, what is that? That's really 1 over 1, or 1. Okay, well, you know what? 1 over 1, if you look carefully, you can also see that pattern here. Go up 1 block, over 1. Look, I'm on the line. Up 1 over 1, on the line. Up 1 over 1, on the line. So I could choose 1 step and go up 2 over 2. I can choose all the steps, go up 8 over 8, or I can do 1 little block at a time. But regardless of how long or short of a segment that I choose along here, regardless of that, I'm going to end up with the same fraction. And so this number is going to represent the slope. This thing has a slope of 1. Why am I leaving it as 1 over 1? Couldn't I just write the number 1? Well, yes, actually I could do that, but because we like to see 1 over 1, oftentimes we will leave our slope as a fraction, and that's okay. If you want to call it just plain old 1, you can do that too. I promise not to be offended. So what about this one? Our rise, we only went 4 up versus our run. This thing went 12 across. So there's my rise, there's my run. Again, if I think about this as a fraction and simplify it, that's going to be 1/3. Up 1 over 3, up 1 over 3. Again, no matter how long or short of a segment I take for this thing, 1/3 always comes back to being my slope every single time. So that is what rate of change is. That's what slope is. Rise over run. How far up does it go versus how far across does it go? So if you can get that in your brain, you're in a great place right now. Do these ever reverse? No, they can't. Somebody had to make a decision and say, you know what, it's always going to be rise over run, because otherwise, man, life would get really messy really fast. Okay, so what does that mean when we start talking about graphs then? All right, so what's going to happen here? Well, if you notice my first graph here, I've got a first quadrant graph. Here's my lovely line going through it. I've got a point here, I've got a point here, I've got a point here. And I'm going to pick 2 points. I can pick any 2 points I want. It doesn't actually matter. I'm going to go with this guy right here and this guy right here. All right, I'm going to go with those 2 points that are on my line. Well, if I think about this as rise over run, let's decide how high is this thing going. So let's take a look at it, shall we? This thing is going from here to here. It's going to go up 1, 2, 3, and it's going to go over 1, 2. So if I look at this is going grand total of 3 boxes up and 2 boxes across. 3 over 2. Ladies and gentlemen, I'll give you 2 guesses what my slope is. Did you guess it? Are you right? So we're talking this is going to be a rise of 3 over a run of 2. Can I simplify that? No, that's a simplified fraction, 3 over 2. Yes, it's improper. Could I call it 1.5 if I wanted to? Yes, I could. This is an approximate value of 1.5. But again, because I want to see my rise and my run frequently, I'm going to leave this as a fraction. And there is my slope, 3 over 2. Well, let's compare what we've got here so far. This is a slope of 1. This is 1/3. We said this one was more steep. This one is less steep. The number 1, I'm sorry, my focus in here is kind of weird today. 1 versus 1/3. Which one is the larger number? 1 is bigger than 1/3, is it not? 1 is bigger than 1/3. More steep, less steep. The bigger the number, the more steep. The smaller the number, smaller the number. Let's reword that, shall we? The closer to 0, the less steep it's going to be. All right? So what does that mean about this? If this is about 1.5, where does this fit with my other 2? Is it between the 2? Is it less steep? Is it more steep? Where does it go? Well, at 1.5, 1.5 is bigger than 1, and it's bigger than 1/3. So of the 3 lines that we've got here, this one is the most steep one so far, because it has more of a rise compared to its run. Bigger rise versus run, bigger number, steeper slope. Okie dokie, what does that mean for this guy right here? Well, you may notice a couple of differences. I do a 4-quadrant graph because why not? But it's also going a different direction, so what does that mean for me? Okay, so again, I can choose any 2 points along here, and you may see that there are several points that are marked out. I'm going to choose this one and this one way over here just to show you that I can. So I'm going to go with there to there. All right? So again, if we think rise, well, that's kind of silly. I'm actually going to go down. 1, 2, 3, 4, 5, 6 down. And 1, 2, 3 across. So I went down 6 and 3 across. Let's make sense out of this, shall we? Up, over. Up, over, up, over. Up is usually represented by positive numbers, is it not? And this time I went down and over instead of up and over. What might make sense right now? If I'm going down instead of up, maybe this should be represented by a negative number instead. I like that because this line is also going left to right, down. We always read left to right, so if I start here and I go this way, it's going down. Versus this one is going up and up and up. So these are all positive. This one's going down. What does that mean for my slope? Well, that means that, let's see here, we're going down 6, so my rise is actually negative. over my run is still 3. Can I simplify this? Yes, I can. That's going to be negative 2 over 1. Negative 2 over 1. That is my slope for this line. Okay, so now, bonus question, of the 4 on the page, which is the most steep? We said that's the smallest number, that's the least steep. This one's in the middle, kind of like Goldilocks. This one's just right. And this one had the biggest number, therefore it was the most steep. Where does this fit? Well, 2, because 2 over 1 is the same thing as 2. 2 is bigger than 1.5. But it's negative. You know what? 2 is bigger than 1.5. This is the most steep line on the page. All right, we're talking this thing goes down 2 for every one that goes over, down 2 over 1. But the negative here doesn't really refer to the size of the number. This just refers to a direction. We are going down. So this is the most steep line, and it also happens to be going down. So it's not the most steep because it's negative. It's the most steep because 2 over 1, is a bigger number than 1.5. All right, so let's tie a couple things together here, shall we? We've got some beautiful visuals to take a look at. Let's take a look at this. So what are we saying? All right, we are saying that slope is rise over run. And rise, everything here referred to rise as being things that are up and down. Well, on a coordinate plane, which is the x and y axis, which one runs up and down? Ah, yes, the y's. So when we talk about the rise, we're talking about the y's. Fortunately, that rhymes. So when we talk about run, we're talking about going across. Well, what goes across? The x-axis. So we're talking here about what happens with the x's. And if we look, we've asked ourselves how far up and how far across. So in both cases here, we are talking about distance. Oops, I can spell. There's a T in there somewhere. And my eraser. There we go. Distance. So there is a formula for this. I do not like to start with the formula because if you just memorize this, man, you don't know what's going on, and I would hate to see that. But I'm going to show this to you because it should make sense. First of all, I'm going to write the letter M. Why? You know what? Many people are not sure why, but the letter M is used to represent slope. And I even Googled it, and they're like, well, maybe it's this, maybe it's that, but nobody's really quite sure. So quite frankly, M is slope. It's a variable, and we don't know why. It simply is. All right, so if I want to show my distance for my y's, well, in math, how do we often figure out distance from one to another? We end up using subtraction to find distance. So I want to find the distance that my y's go, so I'm going to do this with subtraction. The official formula, which I'm not really fond of, goes like this. Y sub 2 minus y sub 1. That's my rise. Okay, hold that thought. Did you hear how I said that? Y sub 2 minus y sub 1. The 2 and the 1 are set slightly lower. I know it's scary looking, but what does this mean? It means that that's a y value and that's a y value. But I don't really want to get confused. So I'm going to name one of them with a name tag of sub 2, and I'm going to name the other one with a name tag of sub 1. That's all we're saying that these are both y's, but they're not the same as each other, so I'm going to give them little name tags so I can tell them apart. It's like, you know, when you're looking at identical twins and you're trying to remember which one is which, look at the name tags. All right, so we got that. So we want to see the same thing happening then for our, put this across here, for our run. Again, it's the distance, how far across. So this is going to be x sub 2 minus x sub 1. Again, to find out how far we go across, we're going to subtract the x's. But they're not the same x's, so again, we're going to put name tags, sub 2, sub 1 on each of those. Why are the 2's first and the 1's second? That's how somebody wrote this formula. Does it have to be this way? Yes and no. All right, so there's some consistency here. So we've got this guy right here. Here's our slope formula. And again, if all you do is memorize this, so help me, rar. Okay, you've got no idea what's going on. Think about what's actually happening. Okay, so let's tell you what, let's go back over to this right here. All right, let's go back to this guy and say, how would this work with my new formula? How can we make sense out of this? Well, let's think about what these ordered pairs are. All right, what is this point? Okay, 2 over 1, 2, 3, 4, 5 up. This is the ordered pair 2, 5 on the coordinate plane. 2, 5. So what is this one? 1, 2, 3, 4. So this one's going 4 over. And 8, does that make sense? It does make sense. Excellent. All right. So ladies and gents, these are the two ordered pairs for this point and this point. This is 2, 5, and this is 4, 8. So we counted 3 boxes up. Okay, nice, lovely. What if we took a moment and we focused on the y's, the part of this that goes up? Here's my y value, 5. Here's my y value, 8. If I'm going from 5 to 8, how far up is that? What's the distance? Well, we counted 3, but if we do 8 minus 5, 8 minus 5, we can see that that goes up a total distance of 3. So it's kind of like we're saying, okay, here's my 1 point. My 1 point is 2, 5. Here's my other point, which is 4, 8. And we're saying this was my first point, so this is my first x, comma, and my first y. And this one, this is my second x, comma, and this is my second y. We're just saying, here's my 2 points, 2, 5, 4, 8, 2, 5, 4, 8. We've got 2 points, and the first x and the second x, the first y and the second y. That's where these are coming from. And we just said that, hey, if we look, we can count 3 boxes up, but if we look at the y values, which are control of the up-down, 8 minus 5 is 3. So when I go to set up my slope formula, slope is going to be 8 minus 5. 8 minus 5, otherwise known as, hold that thought, come right back to it, 3. Well, what does that mean about the y value? Oh, sorry, the x values, because the x's control my run. Remember, the y's are always on top, x's are going to be in the bottom then. So if I look at these points, what's happening? Well, I'm going from 2 to 4. How far is it from 2 to 4? Well, again, if I simply subtract, I can find that distance. So here's my second y minus my first y. So my second y, 8, minus my first y, which is 5. What about the x's? My second x, which is 4, minus my first x, which was 2. And what is 4 minus 2? 4 minus 2 is 2. Oops, I didn't mean to put an equal sign there again. Sorry. And ladies and gents, that's it. That is it right there. Check that out. That slope matches that slope. So we can find it by counting, but we can also find it by subtracting and setting up our ratio. We're going to get the same value for both. All right, one very last thing, and I promise to let you go. I want to do this one more time, but with these guys instead, all right? So if we call this graph number 1, here we just did slope formula for the first one, and if this is graph number 2, let's do slope formula for the second one, shall we? All right, one last thing. Let's look at what our points are. This is negative 2, 3. So negative 2, 3. I want to show you this because of the signs, and this is going to be 1, negative 3. 1, negative 3. With the negatives, this still works. So again, my first point is negative 2, 3, and my second point is 1, negative 3. First x, second x, first y, second y. Finding my slope, what do I need to do? Finding my slope, I'm going to take the second y minus the first y. So negative 3 minus 3. Negative 3 minus 3. Interesting, interesting. Over, what's the distance between my x's? Well, here's my second x minus my first x. 1 minus, are you paying attention to the signs? 1 minus negative 2, because we are always subtracting. So sometimes we're subtracting a negative. And let it be what it's supposed to be, all right? This is going to be okay. What is negative 3 minus 3? Well, we lose 3 more. That's a grand total of minus 6 over. What is 1 minus negative 2? Remember that subtracting a negative is the same thing as adding. 1 minus 2 is actually 1 plus 2, otherwise known as 3. And ladies and gents, if you compare that, you can see it's highly comparable. If we reduce that fraction, that does reduce to being negative 2 over 1. Same value for both. So understanding what slope is important. How far up versus how far over. Rise over run. We can count it, but we can also calculate it. Be able to do both. If you can do both, that puts you in a fabulous spot. All right? You have to pay attention to the details. You got to pay attention to the signs. The two most common errors, people don't pay attention to the positive, negative, and people mix up the x and the y. The rise is always on top, so the y's are always on top. All right? Practice, pay attention, enjoy. Thanks.